Okay. Before before we start the dissection, so first I set up the camera setting. Uh, this is for camera setup apparatus, and you make regulate the focus. If you feel your focus is not aligned with your eyepiece and use the camera, you can use this tool and you can control the special uh, point. So you can regulate the focus and then give you ready to experience. Good. So before start the experiment, okay, before start the experiment, ready, the dissection setup and the uh, the plate. And can you give me the pipette with the tip? Okay. So before we need to ready this point first. Uh, briefly clean up the this point plate. So the solution to be set up in here a little bit. And what we're gonna do is dissect the brain and move the brain into here to here and set up the tissue folder. And ready the tissue holder first and place the tissue holder inside of the solution first. Okay. Ready your forceps, ready your frame, everything. So in the microscope room, uh, this tissue, this plate would be set up in the microscope specific tissue holding plate. I will let you know when we visit the microscope room. We will get what it is. And then, okay, and another thing is we have a uh, uh, this one is not 100% necessary, but to moving the uh, brain, it is good. And give me the flag. Okay. Hmm. So you may have more than this.
Ah, yes, this is just,
Uh-huh.
and today I'm just going to set up. I don't plan to get any data like the
Okay.
intensity, time, and
Okay, I see.
and this was
Okay.
totally different experiment. I just prepared really.
Rain. And we share the vision. And here you can catch the image using the okay. So dissection is the same.
Mm.
The same brain dissection we usually do.
I think the worst situation is if that orange part of the eye is not fully
Ah,
away.
that's right. So orange part can have a GFP signal, basically. So, but you can remove it.
But sometimes when I try, I
Mm.
damage the optic lobe.
Oh, that's okay.
Depends on what you are measuring.
Uh,
PDA, you need the optic lobe.
so today, which GALFO you're using?
Today is, I think at least I want to try EB, but I have
Uh,
EB, MB, FB, and DF.
so what GAL4 are using in this flight?
This is just MB247 over class. This
Okay.
one will not have any signal.
No signal is a control?
No. This was for different experiment I just
Uh,
had leftover.
okay.
So I didn't mind to
Uh-huh.
lose this fly.
Okay, great. So, dissection. It's the same. But the issue is my dissection skill not as good as before. Maybe some damage in the eye. The brain is relatively small in this fly, I think. Because a mayfly, maybe they have a population, many population. So if you grow too much fly in one vial or one bottle, their size may be smaller than the other group because they don't have enough protein in each flies because they have too much population. So
I
they're
mean, they were on no protein diet for a while.
really that's reasonable. Yes. No protein diet, no delta signal, no insulin, smaller body size, smaller brain. That's very natural. So during the development, so is the protein concentration in the food or in the body can affect the body size by affecting the insulin signaling.
Uh, I am just curious.
Mhm.
I mean, I know you are getting rid of the ocelli because you usually
Ah,
work with DILP2, but if
yeah.
I
Okay,
work with,
keep it this oscillate.
I mean,
Oh,
for now it doesn't matter.
uh-huh.
Like, I was just, is it because you are used to, right? It's not
Okay,
like it's.
okay. Just I just leave it to you, and then okay. So in this step, you ready? You dissected the brain, and the next step is what you're gonna learn today. So from this step, yeah, you're doing this every day. But what we're gonna do is move this brain to the plate and holding the tissue using the tissue holder. So okay, this is the variant I'm gonna use to move the flies. Okay, brain is moved to the plate. And first, so so we need to put the brain down. And which side of the brain you want to
I guess
majorly
central, like
uh,
EBFB, something like that.
so Okay, so your main target is EB in this experiment because I need to decide the direction of the position in the brain.
I guess, let's say EB.
Okay, I see. So when you decide to image the elderly body in this experiment, so the brain should be uh, positioned. The posterior part of the brain should be upper because, as you know, our microscope is the lens is inverted lens we are using. So the optic direction is lower to upside.
So I should put like
Yeah.
this.
So
Not like this,
yeah,
but
your
this.
region of interest should be lower part and touch the cover slip in the
So
first
with
part.
antenna lobe down.
Yeah, that's right. So because today we're gonna use the inverted microscope, and then Uh, so place the tissue holder. So tissue holder, I previously immersed in the tissue holder in the solution because dry tissue holder when they put in the kind of in the solution directly, it can make some bubbles. So there's a reason why I pre-incubate the tissue holder and place the tissue holder in here first. And okay. And so focus, make the focus. So this part, this is made by the lead. This is a handle. You can catch the this apparatus using this part and move this apparatus like this and place it. So basically, uh, in theory, in theory and practical, the path of the light is upside down. So these nylon fibers do not harm the imaging, basically. So
But if I, for example, put a PDF, I would
uh,
have to do it differently.
yeah, different position you need to use. So like this. This is the tissue holder and the seam. What we are using it is the nylon fiber, nylon string with we extract this nylon string from the uh, stocking. Is it English? Kind of the uh, some socks, but made by the nylon web stocking. You Korean.
Well, let's say I usually know it from the fishing.
Yeah. Mesh, some kind of the mesh structure. So we need a nylon string. So we extract the nylon string from the uh, So yeah, this is the how we hold the brain, and this type of the brain holding is usually using when you image this part of the brain area. So PI region or this alveolar body or something. But when you image of the PDF neuron, you need to use another method. But in our setup our light path is on the inverted direction. So this nylon fiber do not harm the imaging, even though you are using the PDF because the light path is from the not upside, but it's from the lower side.
Right.
So I think it's good because and then it is better just leave the fly brain uh without any holding apparatus. So I think so. And you move this apparatus and set up the microscope and image.
Mm.
So that's what we will do today. Okay, and I will finish the okay.
For the Shanghai student.